have reached Russ Grease with rwgresearch.com. Open-source-energy.
Hey, what's up everybody? Russ with rwgresearch.com here. Today, this video is about making a hot end. So currently I'm working on the OSD, and I'm going to be making some of my own hot ends anyway. So I thought I'm going to remake the one on my current printer. It's giving me fits. It's just the regular heating block with the like 10 watt or 5 watt heater with a thermistor through it, and it's really annoying. It drives me nuts. So I modified it already with a liner of PTFE like this, and it seems to be working okay, but still giving me fits. So I'm used to having something that I custom built anyway, and originally Jeff built my first hot end and I liked it so much that I'm going to be making one very similar to it. So I made this entire thing in a different video. You guys can check that out. So what are we going to do? The goals are make it out of PEEK because I actually like it. The regular boring J hot end from the original riprap actually works really well, and make it a pretty high wattage heater and make it wrap around this guy like this. And then I'm also going to make it so I can thread something into the bottom. It needs to be that way so I can thread a new tip into it without messing everything else up. So that's my goals. I have a bunch of leftovers and stuff here on the bench from some other parts and pieces, and some of this came from George at Georges3Dprinters.com, I believe. I'll link it in there. He sent me some of this pieces and parts from old heaters and components, but the one on my current printer is actually it's a cheap Chinese knockoff, and unfortunately it's just junk. So these are actually, for instance, here is one of those pieces without the hot end on it. And I really don't like this all metal hot end because you absolutely have to blow a fan across here, and I just don't want to. So I'm not going to. I'm going to be switching back to this old style. So here we go. Starting with PEEK, P-E-E-K. It's a high temperature plastic, and this is 0.75 inch OD. Let's get to building. Okay, so starting out, we're going to be making basically what you see here, this bottom component. This is just an aluminum one, but I'm going to go ahead and make one out of the PEEK. And it'll be pretty well identical to this. This is the way the old J hot ends mount, and I like it, and so I'm going to continue with it. And so we're going to make a piece that looks, well, basically just like this out of PEEK. Alright, so we just hacksawed a 1.25 inch piece of this off. We'll clean it up and get it the right diameter. Okay, so there's this little piece. We got threads on this side, a hole on this side. It's basically the same thing as this right here, a little taller because I may shorten that depending on how much I need to take off here. I gotta take the other printer apart and look. I think there's a little bit of stuff there I gotta get out yet, but yeah, that turned out pretty good. There we go. So now we got to get the and this is only threaded up to a point where I can thread it against there and it stops, so that's it. So we'll cut the end of this bolt off and drill a hole through this, and this is actually going to be our feed through. Okay, so starting out with the end, I've actually got this copper contraption. It's already got threads and holes in there, the wrong size. We'll drill that out and tap it. And then it's got a thing on the back. This is actually a contact that came out of like a big contactor. Something you'd find in a golf cart or something like that. So I'm basically going to take this exact piece, and this is going to thread in so far, and then my hot end is going to thread in the other way so far, and then I'm going to actually wrap my thermal wire around this guy. So I'm just going to kind of trim this up, drill the hole all the way through, tap it the right size, and see how that turns out for me. Alright, for purposes of getting this thing done, this is what it turned out. Threaded through the center, flat on the end. I could still get something. I'm probably going to cut these edges off so I can get a wrench on here if I needed to. Because I do want to be able to take the tip off, but I don't care about taking the rest of this off. So it's threaded all the way through. M6, by the way. Alright guys, so I decided to go ahead and use my old tube to try this out. It actually has a copper insert, copper sleeve insert, and then what I did was I drilled this out to the diameter of 0.154, and then put this in the lathe and actually push the tube in there as it turned. So that gets me a nice compression fitting. So these two pieces need to be fitted like so, and then we'll put the other end on the other side and see how that works out for us. Alright, so here it is. You can see now what I was talking about the little copper insert. So the PTFE goes down somewhere in here, and then there's a little copper insert that's just the right diameter for the filament. This piece is going to go on here like this, and that copper insert is going to allow for the back end of the nozzle to sort of compress onto that and make a good seal. So now we're going to wrap our heating element right here in this section. Hopefully all works. I think I might even try to put the thermistor somewhere right in the middle of this little block right there. Alright, so on my printer the original mount looks like this with the J-head plate that I made. So in this case it fits like this, and I've cut this. You can't really tell, but there's a tiny little slot in there where the PTFE stops, and this whole diameter is actually smaller going through this plastic part. So I made this fit just right, and it clamps like this. I like this easy thread 3D printed threaded thing on the original design. So this clamp like this, that's what actually holds this guy in place, is this clamping mechanism, which this could be better if it was metal. That would really be a better option, but anyway, so the PTFE liner goes all the way down through there. Now there's a little gap in there, you can see, and I probably should fill that in with something, even PTFE tape, just to keep it from doing something silly. Alright, welcome back everybody. It's the next day. I'm inside doing some other things and I got a few minutes. So basically, I'm going to be making the heating element. How am I going to do that exactly? Well, I'm going to be taking this Cattenall D wire. This happens to be 24 gauge. I think this is what I used last time. It worked really well. But, I don't remember. I might have used this stuff. So this is also Cattenall D. Oh, is it back? It's upside down. No, it was right. There you go. So you can see the diameter, the size, and everything else here. This is a spool I bought off Amazon or something that was on sale. Leftover scraps. I'm going to get it all tangled if I'm not careful. Okay, basically what am I going to be doing? First thing I'm going to do is make sure this doesn't go flying everywhere. Okay, so basically what I have here is I have just a regular 12 volt DC power supply. I was going to use a battery, but oh, there goes the coil. Anyway, okay, so I have this connected to an AC supply, and I've got 12 volts here. So what I'm going to actually do is I'm going to take my amp meter, all right, voltmeter at the moment, 12.05 volts, okay, and I'm basically going to take a length of this wire. I'm going to short it across this power supply and check for how hot it gets, basically. Just visually looking, how hot does this wire get. And I'm going to check how much current, and I'm going to just do that for different lengths of wire until I find the right amount of amperage that I know my board can handle, and the right amount of current that I know my wire can handle, and that'll give me basically the maximum wattage without burning the coil or the circuit up. So that's what I'm going to do. Okay, so I've tested the first piece of wire, and I'm just going to go ahead and base it on about 2 amps. So the smaller wire, which I didn't tell you, it is actually 0.0126 or 0.23 millimeter diameter. And it says here 16.7, well, I don't know what that is, but 5.09 ohms per 1 foot. So we could do the calculation. We're at just over a foot, okay, and we've got about 2 amps, and it's not quite red hot. It's actually just below ambient. You have to hold your hand over it to see it, so that's about comfortable. I don't want it glowing red hot. That could potentially burn the coil out, but yeah, it puts out some serious power. So what I'm going to actually be using besides Kapton tape is this. This is exhaust crack leak stuff, and it turns really hard. It's basically sodium silicate, and this will harden. So I'm going to wrap the coil with Kapton tape to keep it insulated. Then I'm going to wrap the whole thing in this layer on layer, and however I need to do that. And then this will actually be my protectant. Okay, so I did the bigger 24 gauge wire, and I need like over 2.5 feet of this stuff for about 2 amps. I think I actually like this stuff better, but you know, if I had to wrap 2.5 feet around a small object like this, I'm gonna have to have a lot of wire. So although I could pump more current through this and get it hotter, I think I'm going to choose the smaller wire just purely because it's less wire. And I think it'll work really well for what I want. Alright, so briefly I'm going to show you guys what I'm doing. I'm going to take this Kapton tape, I'm going to wrap it around the copper part here. And then I've got some regular red wire crimp junctions that I'm going to use for crimping everything together. I've got thermistors here, I forgot the part number, and then I've got some PTFE tubing. I don't know if this is actually shrink wrap tubing, but it's a PTFE tubing. I got it from a guy's house that had a bunch of stuff I brought home one time. This is some PTFE coated, copper coated wire, or silver copper coated wire. I'm just using it because it's PTFE coated here for thermal protection. And then I'm going to basically take this stuff in cotton swabs, and I'm going to put this on here on top of the tape and mix it all together and just go through the whole thing and sort of layer this wire. I think I'm going to go ahead and go with 2.25 amps, which gives me somewhere around like 28.5 watts of power, and it's going to be directly over the center of this guy, so I think that'll be plenty of temperature here. The thermistors I'll add later, but I had them out. And then I'm going to take, yeah, that's what I'm going to do. I have no idea how well this is going to go. This is a trial and error experiment. Alright, so I took one of these red butt splice connectors, and I cut the inside out, and it's a full barrel, which is nice. It's not a half rolled crimp thing. And then I cut that into 2 pieces, and you have to use these to crimp the main wire to your heating element, because if you use solder, it'll just melt off. So you can't use solder. So we're gonna do it this way. Just thought I'd show you a close-up. I also taped up this guy with Kapton tape all the way around it, 400 degrees Celsius working temperature. Thank you, Steve, on the interwebs, streaming live for the data while I was working. So there you go. Now we'll start this process. Alright guys, so to make this splice, I thought I'd get a pretty good close-up. I've wrapped the heating element wire around the wire I want to crimp. I'm going to slide this over, and I'm going to nicely crimp that on there with a pair of jewelry crimp. Actually, these are a pair of jewelry clamps, but any crimps, even a pair of pliers should do good as long as you can crush it good. Alright, and that's that. So, it ain't the best I've ever seen in my life, but it sure ain't letting go.